right, how about we kick off? So again, welcome everybody to today's webinar, API contract testing for a design first world. Let's start off by giving some intros. So my name is Alicia Foreman and I am the Senior Product Marketing Manager here at SmartBear. I work directly with the Pactflow team. I've been working with Pactflow for about 2 years and I recently joined SmartBear as part of our acquisition. Joining me today is my wonderful colleague, Matt. Matt, would you like to introduce yourself?
Always so nice, Alicia. Thank you. My name is Matt Fellows. I am, the co-founder of Pactflow, now part of SmartBear, and also have been a maintainer of Pact for 7 or 8 years now. So really excited to talk with you all today. Thanks for coming along.
Fantastic. When we know we've got Matt here, we know we are in good hands. So let's cover off a bit of an agenda of what we want to share with you. So we've got 2 main points we want you to take away. So we're going to have a look at the challenges of scaling testing in complex API structures and microservices. And then we're going to explore how contract testing with Pactflow, along with Swagger Hub, can come together to solve this. I guess our aims for today are to not only help you reinforce some of the learnings that you already have or knowledge that you already have around maybe these 2 topics, but take away some new information that you can share back with your teams. Before we get into the core content, we know that the SmartBear people love some poll questions in their webinars. So we've got a couple of those to run through. The first one is, what is your experience with contract testing? Just enable a few moments for those to complete the poll. Maybe this is a new topic for you. Maybe you're an expert or you're really close, or maybe you're somewhere in between. All right, and our second question that we're going to have a look at is, get a change of the screen, Matt. Thank you. If you're already using microservices, what is your biggest challenge? What's the biggest challenge that you're facing today? Maybe your teams are really becoming quite coupled. Perhaps you're experiencing growing complexities in test and release cycles. Maybe you're not using microservices. Just let us know. Excellent. All right, so let's get into it. So we're going to kick off and start talking a little bit about microservices and testing in microservices, why it can be really quite challenging. So let's just start with the positives. It's always nice to start on a positive note. So why do we love APIs and microservices? Well, number one, I guess APIs are becoming really central to the core of many internal business functions, and this is really across the board. SmartBear's most recent, or the latest State of Software Quality API report, which was released in 2021. Hot tip, the 2022 edition will be coming out in a couple of months' time from now. That last year's report found that 70% of companies that were surveyed had been developing APIs for more than 3 years. So there is, I guess, an element of established API creation internally. Of this cohort, about 3/4 of organizations are consuming and developing their own APIs themselves. And 2 of the most popular drivers for having APIs internally are to be able to reduce development team time and cost, and to also add interoperation between internal systems, tools, and teams. So APIs and microservices, huge value add, especially when we consider against a monolith, traditional monolith architecture. They enable us to reduce time and cost to get our new features and solutions to market and enable us to fasten those release cycles. But like with everything, there can be some downfalls. And I've chosen this quote from a customer, which is a large banking client. And I think it really paints a picture for us about some of the chaos that can go on behind the scenes when you're trying to scale up your testing initiatives within a complex microservices architecture. So this quote comes from the Executive Vice President of Application Development at this large bank. From the outside, functioning really nicely for those end users, but on the inside, a little chaotic. to make that experience great for those end customers, this particular client has a really large program of many different teams, sprawling teams, all trying to build different components of their services through a microservices event-based architecture. No one's going to be surprised if I say that testing within this environment is really, really challenging. And between direct calls, between RESTful APIs and GraphQL APIs, also looking at third-party SaaS and other integrations, it's a real challenge. And when we first started speaking to this client, they just wanted to get better confidence for their teams to deploy and look at how they can really take back some of those benefits that you get from the microservices architecture. Rather than that being drawbacks from increasing the testing burden. So what this is telling me is that there's chaos going on behind the scenes, but what's causing that? Maybe it's that some of the tools and the processes that were previously used in that monolithic architecture are being applied to this new world, and it's just not working. There's two things or two reasons two ways really that we can look to solve for this, and we're going to run through those today. The first is looking for a repeatable approach to the design and the development of APIs. So that's looking at a design first approach. And the second thing being a need to modernize our testing practices. That's going to lead me into a conversation about testing within a microservices architecture. So if we take a look at the test pyramid, you'll see that this example here, I'm sure most attendees are really familiar with the test pyramid as a framework to plot out modes of testing across the software development lifecycle. One hypothesis that we could say is that that particular client that we talked about earlier had a really top-heavy focus on end-to-end and UI tests, which sit at the top of the pyramid, and in that way mean that they are experiencing longer feedback loops, more effort and more fragility around those tests, but they're getting higher confidence. And of course, the high confidence is the piece that's needed, right, towards the end of our software development lifecycle. I guess the thing that's causing some pain for these organizations around those end-to-end tests can be that they're difficult to debug, that there is a bit of a burden around the test data management. Now, if we look at an alternate view, which is the unbalanced test pyramid, the rebalanced test pyramid, you'll see that we've added an extra layer of testing. So that is about modernizing our testing processes, and contract testing is a way that we can look to calm that chaos that we heard about earlier, and really focus on doing tests where they have the most impact at the right point in the testing process. Now, again, thinking about the test pyramid, much like the food pyramid, every aspect has their, test has their right place in the food pyramid, consuming the right things in moderation. And in this instance, we see that there's a lesser reliance at the top of the test pyramid for those end-to-end tests, still playing a critical role as that gate for deployment. But adding in, bulking up the contract tests and the unit tests earlier in that life cycle, which will enable us to get earlier coverage and more confidence as we go through to deployment. So what I'm proposing here is an antidote to that chaos, and that is contract testing. If we look at testing earlier in the software development lifecycle, we're going to be able to get more knowledge and more confidence to deploy. Contract testing is a way that we can confirm that two separate systems, such as two microservices, are compatible with one another and they communicate with one another. Contract testing answers the question, will my API behave the way that we agree it should? Ultimately, calming down that chaos through a shift left of integration testing feedback loops. Customers who have implemented contract testing in their software testing strategies talk about the benefits such as being able to test a single integration at a time. There's no need for a dedicated test environment. They get fast and reliable feedback on the developer's machine. There are tests that will scale linearly as the business and the microservices grow, and ultimately allow teams to deploy their services independently. Contract testing really provides that level of quality and ownership over quality for everybody in the software development team. Additionally, the flow-on effect is that we can, because we're getting that earlier confidence, we can then reduce the reliance of our end-to-end tests. Of course, end-to-end tests, as I said, really have a place. And if we're reducing our over-reliance on them, we're actually able to maximize the benefits that we get, which is confirming that our application is going to function at every level for that end user. And also, we're going to minimize the pitfalls, which are, potentially slower release cycles, team interdependencies, and the management of environments and data. This then is really the antidote to clawing back some of those pains that we might be feeling in a microservices architecture and actually being able to explore and utilize the benefits. So how do you do contract testing? So there's a couple of frameworks. Matt mentioned earlier that he's been a core maintainer of Pact open source, which some of you may be familiar with. It's a framework that has been around for almost a decade and is used by thousands of teams. It's really the de facto framework for a consumer-driven contract testing methodology. You then have Pactflow. And so Pactflow has been around for not quite as long, about 2019 we launched Pactflow. And Pactflow is the complete contract testing solution. It brings together the foundations of the consumer-driven framework from Pact open source and pairs it with a bunch of functionality and tools and language support, which enable teams to grow and scale their use of contract testing as they need. So 3 key points about Pactflow. It's going to provide visibility into API usage and prevent breaking changes. This is really giving teams across the board and members of the teams across the board detail of their microservices architecture and then giving them the confidence to deploy. There in the middle, we've got a really multi-prong approach to contract testing. So not only a multi-workflow support, but also multi-protocol and also language support for more than 11 languages. And last but not least, if you're familiar with some of the other products within SmartBear, there is an open source solution, and then we've got our commercial proprietary offering, which has been designed for teams and enterprises to be able to scale that solution. And that looks at ways that we can decouple those teams. They can still work together really harmoniously with proper communication and collaboration. Plus, you get all of those nice enterprise-ready features, such as your security governance features, and then able to have flexible hosting options. All right, so I have discussed the challenges of testing and microservices, those complex architectures, that chaos, and I've talked about a bit of an antidote, which is contract testing. And I'm going to hand over to Matt, and Matt is going to talk about what a microservices API development workflow looks like. So that's coming back to that process piece, looking at that through a design first lens. And then how we can start to create a repeatable development process that can work at an enterprise scale. Matt's also going to give you a bit of a glimpse of how we can layer in contract testing to improve those processes and the overall outcomes. Matt, handing over to you.
Thank you, Alicia. Before I do get started, I just want to quickly make a note here that as we go along, there will be time for Q&A at the end of the session. So do take advantage of the Q&A function in Zoom, and we'll aim to get to them at the end of the session. Okay, so let's talk about what an ideal development workflow would look like for APIs. So ideally, what we want is a way to be able to agree on the design of an API, some set of requirements, and then develop it and test it in parallel. Enable teams to work independently, but of course, preventing the need to do rework as we go throughout the process. So really the same problem we've had throughout the industry for eras. And of course, one of the main challenges of working in parallel is that teams can make assumptions about how other teams are working. So this could be via the use of mocks or expectations on how an API should work that are just misaligned, or things like the requirements themselves, the document we're working from has changed, and the communication of that change was poorly managed. So we refer to this problem as drift. This challenge is drift, and it can happen from either side of a particular integration point. For example, the provider may not actually implement the version of the specification, and so there's a misinterpretation there, or there's just a misimplementation there, and the consumer will then obviously have a problem trying to communicate to that particular service, and of course vice versa. So we're going to talk about drift later. But of course, these drifting causes problems in the life cycle because we often catch them later in the development life cycle, usually after it's been pushed to a development environment or a staging environment, or sometimes later. And we have to go back and fix bugs, rework. And of course, this has cost us the overall cost of development increases. So we're going to look up next about the first stage here is design. How do we solve this problem? And this is where the idea of design first comes in. So what is design first and why do we care? Well, design first is basically where we write down our API design in advance in a way that both humans and computers can understand before we start writing code. So, usually, in some software project, we would write down some requirements somewhere. An API specification is a way of standardizing or expressing these requirements in a way that's specific to APIs. Design first enables us to do a few things. The first one is aligning teams around the specification. We've now got an agreed artifact that we've all come together to create that outlines what it is our API is going to do. This means we can get alignment from teams. It means we can start to build from this shared source of truth. We can apply governance and standards to it. And it really is our first step in bringing repeatability to this chaos we talked about earlier. The second thing is it gives us a really good feedback mechanism and early feedback. Key stakeholders can interact and work on it, and they can iterate on changes in a fraction of the time they would with real software. And the third one is it enables us to unlock a bunch of new workflows that probably weren't accessible to us before. So because we've agreed on a specification and a way to design, build our software, we can now unlock a test approach. We can start to build our test approach. And because we can trust this artifact, we can build around that. And also because it's a machine readable format, it actually enables us to do a bunch of really cool things. And one of those things, for example, would be to generate a mock service from that specification. So we can start to test against this and build our API clients against it to see if this is actually going to be the API structure we need before we've actually built any software. And because it's this machine readable format, we can do this kind of thing. And so with RESTful APIs, we would use a tool called OpenAPI. In asynchronous, we might use async API, which we might talk about later. But with OpenAPI, it's really the industry standard for documenting RESTful APIs in a way that both humans and machines can read. Ultimately, they're going to be in a YAML or a JSON file, but as you'll see, there's other ways to actually author these files as well. Now, because they're machine readable, as I said before, it can enable some really cool things. So, for example, we can use it to generate server stubs that our provider can use to immediately start building a compliant server. And we can also use it to generate API client code as well. They'll be able to interact with that server to save you having to write code. So really just rapid scaffolding tools. We can also use it to generate mock services, as we talked about earlier. Previously called Swagger, SmartBear has donated this open source initiative to the Linux Foundation and has continued to support the community through the open source tools and development of that standard. Now, this is really where Swagger Hub comes in. Swagger Hub is a commercial service. It really takes the open source ecosystem and all the benefits we just talked about in design first and wraps it up into this single service that provides a centralized authoring and collaboration experience around that, as well as the ability to design, iterate, publish, version, and all of this around your documentation for those APIs. So it's really that place that we would start the design first journey. All right, so we've seen a bit of the benefits of design first now. We've also talked about contract testing and heard about how these approaches and tools solve that problem, as well as their open source and commercial counterparts. So let's discuss how these approaches and tools can work together in a mature development workflow. So as we talked about, step one is always going to be authoring this specification, the OAS file. It's going to be the source of truth that we use to kick off this entire workflow. And of course, that's going to happen inside Swagger Hub. But what we can also do, though, is we can bring Pactflow and its data from the contract testing side of things, and we can bring the visibility of the consumers to this design stage. And that helps us inform how we can change the design in such a way that won't impact clients and also prevent breaking changes right back at the design. Of course, from there, we can iterate on design, we can involve other stakeholders, and we can essentially sign off and publish new versions. Once we have published this design, we've now opened up the ability for development and testing and other processes, documentation and so on, to kick off from this process. They can all happen in parallel. So in the case of development, we can use the Open API file to generate code that we can use to rapidly get building on either the consumer side of an integration point or the provider side of an integration point. We can also then introduce contract testing at this stage to add coverage and get well fittedness, so we know how our consumers are actually using a provider, and also verifying the provider to make sure that they're not out of sync with the consumer and out of sync with the actual Open API that we're using. So it's going to prevent this drift throughout the entire development journey. Down here in the testing stage, again, we can now build our test approach around the Open API spec. And really what you want to do here is bring a tool, a functional testing tool, such as Ready API, or open source tools like Dread, which will read in an Open API file and then issue requests against your provider to make sure that it stays compliant, and all the assertions built into it will make sure that it's compatible with that Open API spec. Moving through the journey here, as we've progressed past development and testing, when it comes time to release, again, we're going to leverage the capabilities inside of Pactflow here, where we've got all the visibility of the consumer contracts. So this is what the consumer needs of a given provider, and also what the providers can do. And we've got this visibility about the integration across the ecosystem. And so we can ask the question, is it safe to release, to prevent these breaking changes at the point of deployment? And lastly, because the Open API specification has made its way through this journey, we know that it's come from a source of truth and it's tied back to the initial design and implementation. We know it's always up to date and it's correct. And so we can know the documentation we get published through this is going to be trustworthy. Okay, so let's dive a little bit deeper, and let's zoom into the provider version of this flow to see how we do this, or the API producer. So again, we talked about it before. Step one is always going to be starting with the design. That's going to be the common point we talk about through all of these workflows. Once you've built this design, though, we can now use tools, as we said before, perhaps to generate your provider to get going rapidly. So this is where the code gen comes in. We can generate service stubs that the provider team can then implement to build a OAS compliant server. We can start to form our test approach here. So again, we're going to pick a tool like Ready API or Dread, which is going to read in that spec, and it's going to be able to test our provider to make sure that it doesn't drift from that provider specification. The combination of the Open API specification and these test results, this is what we call in Pactflow our provider contract. This contract gets uploaded to Pactflow and says this particular version of a provider implements this Open API specification, and here is the evidence to say that that's the case. And we can start to use this information when it comes to doing release checking. So at the point, we then publish it to Pactflow, and now we can use that tool we mentioned before, where we can say, is it safe to release this version of the provider to production? At this stage, we haven't built any consumers, so it's always going to be safe. But obviously, as you iterate on the API, consumers will start to come into the picture, and we'll be able to do this breaking change detection at the point of release. So if that passes, we should deploy to production. And if it doesn't pass, we should go and review what happened and find out, have a chat with the other team and have a communication session, really enabling the communication session. We're going to cover what contract testing looks like in a bit more detail later. So we'll dive right into that, so we can sort of just gloss over the high level detail for now. The other thing I want to briefly mention is going back to those mock services we talked about earlier. Because you can take the spec and turn it into a mock service, you can actually apply this the same process, but not to your real provider, to a mock version of your provider. And so this means that you can build your test strategy early, you can apply it to your mocks, you can promote that through the system, and then when the real provider comes along, you can just do the exact same process to your real provider. So it's a really good way of, as I said before, enabling teams to work independently while also getting all this extra work going and building up this validation process. Having a look at the consumer side of this equation, again, we'll go through the workflow here. Always step one is going to be the design. But from this design, we can start to build out our consumer. You could build it from scratch, that's fine, or you could also use those code gen tools I talked about earlier to build a OAS compliant client. From here, we now need to test our consumer. So what we want to do at the end of this is have a set of tests that check the behavior of the consumer of when it talks to its given provider, and get a narrow set of its requirements that it needs to get its job done in the form of a contract test. So here you have two choices. You can choose to use Pact, for example, and you can write your consumer contract test with Pact, or you can use one of the adapters that we provide that can take your existing mocks and convert those into a contract file. We'll talk about this later, but at the end of this, we have a tested client, and we also have a consumer contract, which has all the information, all the requirements, if you will, that this consumer has of a given provider to be able to get its job done. And again, we're going to be able to use this information to make decisions about whether it's safe or not to release later on in the pipeline. We take this contract and we publish it to Pactflow, and then we use that facility to ask if it's safe to release this particular application to production. If it's safe, then we can obviously deploy it. If it's unsafe, again, we're going to go back. We're going to have a chat with the other team. And again, this is really just facilitating that conversation. Okay, so hopefully we all have a better view of the overall API development workflow now. As there is abundance of materials and videos on how to implement a design-first workflow in Swagger Hub, we're just going to keep the rest of this session focused on how contract testing could augment this process. We'll then take a look at the specific features in Pactflow that will support it, and then look at an example that walks us through the steps we just discussed. So one of the challenges of a design-first workflow is that at design time, you may not have up-to-date information on how a given API is used. And this can make it difficult to make informed decisions about proposed changes to an API. It's actually particularly pertinent as we evolve the API after the initial design. So usually there's a lot of workflows that happen early on when you're building a brand new API, but once they go into production, this is actually when bad things usually happen. And so this is where we need to find a solution to this problem. Any changes to this spec could break a consumer. And so normally to address this, what we do is we introduce a very strict backwards compatibility versioning policy, which basically says you cannot remove or rename a field or an endpoint. If you do that, it must require a major version bump, or you can't change the type of field, for example. But API versioning is actually quite costly. Development teams must build it and then, of course, test it and release it. They then must support it and maintain it over a period of time. We also need to communicate this to our consumers that there's new versions and try to get them to upgrade. And so what you end up happening usually is that you have lots of versions in production, and different consumers are using different versions of your API in production. So now you have to support all those permutations at the same time. So this actually creates a large maintenance cost. And of course, when it comes to retiring certain endpoints, if you need to do that, is also quite an activity to coordinate. So what if we could avoid this altogether and be confident in our changes? Well, this is where contract testing comes in. It gives us this visibility and the confidence to avoid breaking changes. So the workflow that we built in Pactflow to support this mode is called bidirectional contract testing. It's a different form of contract testing that's exclusive to Pactflow that complements our existing support for consumer-driven contract testing with Pact. So if you are coming from that background, this workflow is a little bit different. I like to think about this as our ability to upgrade your existing tools and processes into a contract testing solution, which helps you, improve the ROI of the initiative altogether, because you're going to reuse your existing tools, right? So it's particularly well suited to design first workflows, and it's also really well suited to retrofitting onto existing systems where those tools and processes already exist. So how do we get this improved ROI? So the first thing is, as we talked about, you're going to be able to reuse those mocks that the tools you use, so mocking, API provider, testing tools, and so on. And so this just simply means that there's less requirement on upskilling. You're already using these tools, you're already familiar with these tools, and hopefully you've already got those in place. So it really means you can get involved much more quickly. Because you're going to reuse existing tests on both sides of the integration point, then in theory, if we can just convert those into a contract testing solution, then you're going to rapidly increase your coverage across the system much more quickly than you would if you're writing it by hand from scratch, of course. And the third one is it actually enables more team members and roles to get involved. So Pact is very much a developer tool. It really is mostly used by developers in a unit testing context. But this type of testing can be done at a black box kind of style. So that does mean that it expands beyond developers into QAs and SDETs and so on, who may not have access to the code, but can still perform testing that gives us a level of comfort we need to give us confidence to deploy. And so if you do all those three things, it's clearly going to improve the ROI for your contract testing outcomes. So let's have a talk about how this actually works now. So we're sort of zooming right in now into the contract testing phases of that workflow that we talked about before. So the thing about bidirectional contract testing is it actually has two separate contracts. We have a contract for our consumer and a contract for our provider. And we're going to work through this now. Just note that you can start this whole process from the consumer side or from the provider side. It doesn't matter. And both the consumer pipeline and provider pipeline are still going to be completely separate. This diagram is just going to help you show kind of how it would all work together. So starting on the right-hand side of the diagram, which is just for some reason where I always put the API providers, we're going to start with the Open API specification, as of course we talked about earlier. And we're going to bring our own functional testing tool here. So Ready API or Dread, for example, and that's going to take that Open API spec and verify our provider. And we call this verifying our provider contract. This is basically making sure that the provider implementation doesn't drift from the implementation. On the consumer side of this equation, we're going to write a series of tests for our consumer against some mock. So again, we can use Pact here, or if you've got your own mocks, or if you're using your own tools like Cypress or WireMock, you can take those mocks and convert them into a Pact file. So as long as your consumer is using these mocks, to give us confidence, your consumers actually needs those things. And it's a good reminder here that we really want to make sure that the information, the contract that we generate here is specific to that consumer down to the field level. We don't want it to be saying, well, all of our consumers use the same endpoint. Here's the 20 fields on that endpoint that everyone should have. We should all have that. Some of our consumers might only consume a subset of those fields. And it's really important that we capture this because that's actually going to be how we can give the information to the designers at design time to say that field, no one's using it. You can get rid of that. It's safe. So we have our consumer tests. We then generate a consumer contract at the end of that. So now we have a consumer contract on the consumer side that says, this is what I need of a given API to function correctly. And on the right-hand side, we have our provider contract. And that says what I advertise as the capabilities of that provider. And both of these things get uploaded to Pactflow in their own CI/CD pipelines. And then before we release the software, we then ask Pactflow, is it safe to release this to production? There's a tool called Can I Deploy that does this. And what it's going to do is it's going to check the consumer contract. It's going to find all the endpoints in it and go, do those endpoints exist in that OAS? If the answer is yes, it's going to look at the fields it needs. It's going to say, do those fields exist in the OAS? And if the answer is yes, then it's going to be safe to release. If the answer is no, then it's going to prevent us from making that change. And that happens whether you're doing it from the consumer side of the equation or the provider side. If the provider removes a field that's going to break a consumer, it will prevent you from doing so. If the consumer adds something that the provider doesn't actually have, it's going to prevent them from doing that as well. So we talked about Can I Deploy briefly just now. Let's zoom into that just a little bit as well. So it's one of Pactflow's most powerful features. It's we call it Can I Deploy. It's available both through the user interface and through our CLI. And we can use a feature to gate a release of a change into production. And we do that by ensuring that the deployment is compatible with any of the integrated applications in that target environment, for example, production. And it gets all this information from all those consumer contracts, from the version information of all the applications, knowing about which environment things are being deployed to, the verification results, and all these things. And it builds up this gigantic matrix of information that knows which environment and which applications are compatible, which applications are linked to each other in which environments. And that is what's going to power the decision-making to say, is it safe to make this change to production? So, back in the old days, you might remember, release managers or these kinds of people creating large, tabular formats of applications and environments, and they would color in the different boxes there to say which applications had been tested in those environments and which one could be promoted to the next environment. It's a bit like that, but just a modern version of it. All right, so hopefully now you've got a better view of this overall development workflow. We've dived a lot deeper into that contract testing feature to sort of see how that works. What we're going to do now is we're going to try and put all these pieces together in a bit of a workflow just to hopefully make it all really concrete for you. Okay, so the use case here is going to be a little product catalog application. We're going to have a little React website that's talking to a product API that's going to present products onto a page. We're going to write our provider in Node.js, and we're going to use Dread to test it. And we've got a little website written in React that we're going to use React to test, use Cypress to test it because we love Cypress. It's a lovely little open source tool, and our team's familiar with that technology, so we want to keep using it. It also has this really great network mocking feature, which we're going to take advantage of to mock out the back end. Excuse me. And mocking is a really useful thing. We want to do mocking in this kind of testing. It enables fast, deterministic, reliable tests. But of course, mocks can drift from reality. So we're going to show how bidirectional contract testing will enable us to use mocks in whatever tool we want to use that's comfortable and ergonomic for the team, but prevent that from drifting from the reality. And then we're going to see, we're going to use GitHub Actions to test this and push it through our CI pipeline. And of course, we're going to see how Swagger Hub and Pactflow, will support this workflow. All right. So as we talked about, step one is always going to be designing the API in Swagger Hub, or designing our API, and we do that inside Swagger Hub. So we don't need to look in too much detail here, but we've got this big, OAS file. We've got a few endpoints there to create, update, and get products. If we zoom in a little bit here, we can see that the schema for this product endpoint has 5 properties: ID, type, name, version, and price. There's a couple of mandatory fields there, and the price is a number. So we've now designed our API. Of course, we can go off now and create our API and build it. So let's assume we've built our API locally. We now need to make sure that this API is compatible with the OAS. So this is where we bring in our functional testing tool. In this case, we're going to use Dread to do this test. So you can see here, we've kicked off the Dread process. Dread is going to pull the Open API spec in. It's going to read those 3 endpoints that you saw before and make sure that there is that the locally running provider implements those endpoints and has the correct shape of data going back, the right response codes, headers, and so on. And you can see here that the test has passed. Cool. So it's that time, we're feeling confident now. We've implemented our provider. We've tested it locally. Let's push it up and let's let it run through, our CI/CD pipelines. So again, we're going to use GitHub for this. What we do is we push it up. Our pipeline is going to run that process from build, test, and then release. And what we do here is we use Pactflow's can I deploy feature to gate the release to make sure that when we do push this out, we're not going to break anything. Now, you can see that it's passed here because the consumer doesn't yet exist. So, of course, it's safe to release to production. We can't break anybody just yet. So, of course, the pipeline goes through. We deploy to production. We also tell Pactflow that that's happened. So, at the end of this step, we've now designed our API, we've built our API, and we deployed it to production. As far as Pactflow is concerned, Pactflow can now see this contract, the provider contract. It doesn't know any consumers yet because no consumers have come along. And we just get a bit of a sense of it. Here's the provider. This is the version that's in production. And this is what the provider is capable of doing. So got this little Swagger UI render here. So now it's time to look at the consumer side of this workflow. As we talked about before, we're going to build out our consumer application. Again, I'm not going to show you how you build this, but let's assume we've now built our React website. And that React website makes calls to that back end. And we're going to write some Cypress tests to test this application. So over here, we've built our little Cypress test. Doesn't matter if we don't know Cypress, but you can see what we're doing here is we've created a little test phase here. We've got the network mocking tool that's going to mock out the back end for the product call. And it's going to return back some data in that case. We're then just configuring the Pact adapter here. So as I alluded to earlier, we have a few adapters that can take some common mocking tools and convert those into a consumer contract. So what this is going to do is it's going to look at the Cypress network mocking, and it's going to convert all those network mocks as they get used into a Pact file. And it's only going to put the ones in there that the tests actually use. So we know that the consumer actually makes use of those endpoints. We then actually run the tests. So this is basically Cypress speak for clicking around the interface and making sure that the network call worked correctly and that the page is rendered correctly. And we've also got a lifecycle hook here that runs at the end of the process just to make sure that the endpoint was called properly. So at the end of this all, we now have our consumer contract, which is just a flat JSON file. Excuse me. You can see there, it's got the get endpoint for a particular product, it requests some headers, and it gets back a body. And specifically, it uses ID, type, name, and price, which we saw before is a subset of what the provider can actually provide. So again, we're now going to push up our code to GitHub and GitHub is going to run this pipeline just like the provider did. So let's assume we've pushed our code up, we've committed it, we've pushed it to GitHub, and GitHub has now picked this up and running with it. So you can see here that it's done the tests have passed. It's asked Pactflow, can I deploy? Can I deploy? Said, yes, you can definitely deploy this. And therefore we hit deploy, we push it out to production. And now we've got our application in production. So if we just take a quick look at what Pactflow sees here now, we can see that we have increased visibility on this integration point. We've got the visibility on what the consumer contract is and the provider contract. So you can see it says a pact between the product website and the product API. We can see that both applications have now been, the integration is successful, that both applications have been deployed to production. We can also see the expectations of the consumer for a given provider. And if we expand that open, we would see the details of those HTTP requests that the consumer needs to be able to do its job. So we mentioned the matrix before that the can deploy uses. This is a bit of a sneak peek into what that data is. So you can see here, we've just pushed up one version of the provider and one version of the consumer. So we have a single row in our matrix. And you can see that some version of the consumer, which is on the main branch and has been deployed to production, is compatible with another version of the provider, which is on the master branch, but has also been deployed to production. So what this is telling us is that those applications are both in production and they're both compatible with one another. This is kind of the data or the subset of the data we use in that kind of deploy feature to make sure things are safe. So let's imagine now we're making a change to the process and we're in an iteration planning session and there was a new feature requested. Let's say to only display a certain product or a product if the visibility field is set to true. So let's say we update our OpenAPI spec and we also update our consumer to expect this new field so that when the field says if visibility equals false, we won't display it. And if visibility is set to true, we will display it. So we'd update our test, of course, accordingly to deal with this new situation. And of course, we get a new pact file that has an updated expectation on the data that comes back from the provider because we need this new field. But the provider team hasn't yet had a chance to implement this new feature. The consumer team is ahead of the implementation. So if we were to push this change up, this is what the pipeline would look like inside of GitHub. You'd see that basically because the provider hasn't implemented that change, and more importantly, that the provider isn't in production where we need to deploy to, this is going to fail. The can deploy check will fail because it's not safe to deploy this to production because the production version of the API doesn't know how to respond to the visibility field. And of course, this process works the other way around as well. If the provider were to remove a property, we would also get essentially the same failure. So of course, the teams need to go and have communication with one another. If it was being removed from the provider, they need to talk about how they would perhaps add a field, expand and contract, or if they were going to use versioning, whatever process they agreed on to do that. But the key thing is we have guardrails in place to enable teams to work independently at speed. And if for the reason they get out of sync, we're going to have a way to catch this process pretty early. And the can deploy feature actually soon will be available to be run on your desktops. So you'll be able to run that as a pre-commit hook, just like you would with Pact. Just zooming in here in that failure, you'll be able to see if it does fail, you can see that we'll get the feedback inside of Pactflow that says, well, this integration is not valid. We can see exactly why. So here's a message specifically down to the field level. The visibility field shouldn't be there. It's not expected. We can see where in the OAS it's incompatible. And so, we get this feedback overall as to why and where the problem has actually occurred. So it really helps you, put an X-ray lens on why the integration itself has actually failed. And again, just wrapping this up, if we look at the matrix from before, we can now see there's a new row there for the add breaking change branch, which is obviously designed to show a breaking change. You can see that it's incompatible. And you can also see that it hasn't been deployed to production yet. The one that's in production is still safely there, is safely working as was before. So, again, it's prevented us from pushing a breaking change into production, but we're going to get the visibility about which versions are compatible and which versions are not compatible. Okay, so that concludes the end of the use case. Let's recap a little bit about what we discussed and what we learned today. So we looked at how microservice architectures present a number of challenges to development teams today. and that we're seeing this growing pain point around large-scale microservice rollouts, and teams are struggling to deal with essentially the chaos of microservices sprawl. Specifically, we saw how Pactflow and Swagger Hub can be combined to help address this by increasing the quality of your design-first workflow and navigate those complexities. Specifically, Swagger Hub can be used at the starting point here to unify teams around that single source of truth, which is the Open API spec. We learned that a design-first workflow enables teams to work independently. And it's essentially the foundation of this repeatable process for API development. We saw that Pactflow brings that increased visibility into how consumers use your actual API, and specifically enables us to work safely as well as independently. Because we can work safely, we can prevent these breaking changes from going out to production, and hopefully we can also reduce that need for API versioning, so to avoid you having to maintain these different versions of software to get through it all. So I hope you learnt a lot through that process. I'm really looking forward to seeing any questions you have. I'm going to hand over to Alicia now to conclude the webinar, and we'll get to Q&A shortly. Over to you, Alicia.
Awesome. Thank you, Matt. Thank you so much for taking time to prepare that content. There's a lot in there, and I'm sure that those who are here today or those who can't make it are going to be able to, jump back into the recording and have a bit of a deep dive. So before we roll through to questions, just a note on that, if you do want to, if you do have a question for Matt or I, please pop those into the Q&A chat box. So in terms of, moving forward from here and, wanting to get started, we have another quick poll to pop in, and just wanted to ask you, which parts of the API development lifecycle are you most interested to learn more about? Lovely. Thank you so much. That will help us help you. And then second to that, if you really enjoyed the content for today and you're ready to get your hands on the tools, you can actually get started today. So suggest that you pop over to the Pactflow documentation. The quick link there to get to that is go.pactflow.io/design-first. And there you will find the quick start guides for implementing this yourselves. Just noting that you'll need to have both a Swagger Hub and a Pactflow account. You can create a free account for both of those products if you don't already have one, and the links are in that page.